This kind of question is very similar to another type of question that you might come across in this topic. It usually starts off like find the range of k for which this curve is always positive. I have actually another video on that type of questions. I will post that link in the description below. But here's an example of that kind of question. Okay, it pays to spend some time to really understand why they are different. Okay, because a lot of people get confused between the two and end up using the wrong solution for both. Okay, so how are these two questions different? Let's look at the first question. I say show or prove that y equals to that whole equation is always positive for all real values of k. Okay, and in the question below, it says find the range of k for which that equation is always positive. So you can see how it is confusing, right? These two questions sound almost exactly the same, right? Therefore, like everybody gets confused. Okay, but if you think about the implications of the phrasing, okay, then you can start to see how they are different. If you look at the question on top, okay, let's look at the question below first. Okay, it says find the range of k for which this is always positive. So that implies that your graph, right? There's a range of k for which your graph is always positive, right? U-shaped and above the x-axis, right? If any point of your graph reaches below the x-axis, that will make it negative. Okay, so there'll be a range for which your graph is U-shaped and above the x-axis, and a range for which it cuts the x-axis. So there's a portion of your graph that is below zero. Okay, so you must identify the range that shows this case. For the question on top, you're supposed to show that this equation is always positive for all real values of k. That means there's only one scenario, and it's like that. It's a U-shaped curve above the x-axis. So what does this imply about your discriminants in that case? Okay, it must mean that your discriminant for, let's say the question below, right? Find the range of k for which this is always positive. There's a portion of your discriminant. Let's say your discriminant is an n-shaped curve. There's a portion that will be below zero. Okay, this will be the portion that you want to show that your original curve has no real roots. If you look at the positive portion of your discriminant, that would indicate the second scenario where your original graph has two real roots and a part of it is below the x-axis, which makes it negative. All right. How about the question on top then? Okay. For the question on top, you're asked to show that the curve is always positive for all real values of k. So this implies that your discriminant is always negative. Okay, the easiest case is if your discriminant is a constant value, right, and it's negative, let's say -5, right? That will imply that no matter what value of k, no matter what the values of k are, right, your discriminant is always going to be negative, which proves this case. Okay, but your discriminant could be a quadratic curve as well, in which case you need to show there's an n-shaped curve and the maximum value is negative, right? Let's say it's -2. Because if the maximum value is -2, then all other values will confirm be negative, right? Yep. So recognizing and distinguishing between the two different types of questions will show you or will inform you like which solution to use, like which solution is required of you. Okay. So let's focus on the top question now. Like the previous question, right? You want to try to draw the curve, the original curve, right, and see what it might look like so that you will be clear about what conditions you need to show. Okay, so for this to always be positive, right, the original curve needs to be U-shaped above the x-axis. Okay, so there are two conditions that is required. One is that it is U-shaped. Okay, so how do we know whether this is a U-shaped graph or not? Okay, from this equation, right, you can see the highest power of x is square, right? So this is a quadratic graph. That makes it either U-shaped or n-shaped. To determine whether it's U-shaped or n-shaped, we need to look at the coefficient of x squared. If it's positive, it's a smiley face, therefore it will be U-shaped, right? Coefficient of x squared more than 0, right? If the coefficient of x squared is less than 0, then it will be n-shaped, it will be a sad face, right? In this case, the coefficient is 1, right? There's nothing in front of x squared implying that the coefficient is 1. Okay, since 1 is more than 0, it must be a U-shaped curve. Okay, so the shape is fixed already. We don't really have to worry about that, right? What isn't fixed is the value of k, or rather your discriminant, right? That one is unknown. We need to show that your discriminant is less than 0. Okay, so let's go ahead and find the discriminant. Okay, sorry, wait, let me elaborate a bit more on this point. So if your discriminant is equal to 0, right, sorry, this is discriminant less than 0. If it's equal to 0, you will touch the x-axis at a single point, right? So this scenario will not show that your original equation is always positive, because there's a single point down here where y equals to 0. And 0 is not positive, right? It's not negative either, right? But yeah, this question wants it to be always positive. So you can't have y equals to 0. Right? The other case would be if your discriminant is negative, then there's clearly a portion of your original graph that's below 0. Okay? We can't have either of these two cases. So your discriminant has to be negative. Let's find our discriminant. Discriminant is given by b squared minus 4ac, right? We have to identify what's our values of a, b, and c, so we can substitute in there. Our value of a is the coefficient of x squared, which is 1. B is the coefficient of x, which is k. And c is our constant at the back, right? K is a constant, so this whole portion, right? K squared over 2, k and 2, that whole thing is a constant. So c is k squared over 2 plus k plus 2. Alright? So substituting in these values, right, will give us k squared minus 4 times 1 times k squared over 2 plus k plus 2. Okay? So now here it's important to note that we do not add this constraint here. We need our discriminant to be negative, but we have to evaluate what our discriminant is and show that it is negative. If we impose a constraint from the start, it kind of becomes a circular argument. Sort of like saying that, okay, let's assume that our discriminant is negative, and then now let's show that it's negative. It doesn't make sense, right? That's why if you add this inequality at the start, you will be marked wrong for presentation. Okay, so let's evaluate, let's expand this, right? You will get k squared minus 2k squared plus 4k plus 8, still within the brackets. And then when we open up the brackets, we have k squared minus 2k squared minus 4k minus 8, which is negative k squared minus 4k minus 8. Okay, so our discriminant uh, is given by this equation. So let's write it out. Discriminant equals to negative k squared minus 4k minus 8. Right? If you have an equation like y equals to negative x squared minus 4x minus 8, you can tell that it's a quadratic equation, right? Because of the square here, right? And the coefficient of x squared is negative, so it's an n-shaped graph, right? Now we are replacing the y with discriminant and the x values with k. So we can have discriminant on the vertical axis and k on the horizontal axis, right? We need to show that our maximum value is negative. So how do we find the maximum value? We can do that by completing the square, right? So, okay, let's complete the square. Remember, when you complete the square, your coefficient of the square term cannot be anything other than 1. So we factorize out negative from the first two terms. Okay, so you have k squared plus 4k within the brackets. Okay, and then we are going to make use of this special identity for those who have forgotten how to complete the square, right? A plus b squared equals to a squared plus 2ab plus b squared. Okay, we want we're going to assign k squared as our a squared and 4k as our 2ab term, right? We want to force a b squared term to come out so that we can factorize it into this squared term. Okay, so I'm going to add 2 square, right? Because if 4k is 2ab, right, and a is k, that will imply that b is 2, right? It's half of the coefficient of k. So I'm going to add 2 square, all right? And then I'm going to just bring this negative 8 down. So the reason why I want this is so that these three terms, right? This is my a square plus 2ab plus b square. This can be factorized into k plus 2 square, right? But by adding this 2 square, this term here, right, I'm changing the value of my discriminant, right? We can't have that. Okay, we need our value, the value of our discriminant to remain the same. So we minus 2 square again to make the net change 0, right? So we are not changing the value of our discriminant. We are just rearranging the terms. Okay, so negative 2 square is negative 4, still within the brackets, right? And then the negative 8 still remains. Let me move this curve away to the other side. Okay, right. And then from here, let's continue up here, right? When I bring the negative 4 out of the brackets, right, that's the opposite of factorizing out negative 1. Okay, so when we bring it out of the brackets, we need to multiply by the negative 1 outside. So I will have negative k plus 2 square plus 4, because negative 4 times negative 1 is plus 4, is positive 4, then minus 8. And finally, we will get this, right? Negative k plus 2 square minus 4. Okay, so yeah, let me rewrite this, right? Discriminant can be written as negative k plus 2 square minus 4. So the thing about the completed square term is that it tells us what the maximum or minimum value is just by looking at this expression. Okay, just the intuition behind it. Um, we know it's an n-shaped curve because if we expand this bracket, right, we're going to get negative k squared plus something minus 4, right? So negative k squared, the negative coefficient of k squared implies that it's an n-shaped curve. So it will be a maximum value that we are looking for. Okay. So to look at the mathematical expression, right? How can we tell what the maximum value is? If we look at this term and cut it into two portions. Okay, we want to maximize this value, remember. We can't do anything about the negative 4 because it's a constant, right? It's fixed. We can adjust the value of k here to try to make the overall equation as big as possible. But if you look at the squared term, right, the fact that this whole thing will be squared implies that it can never be negative. Because remember, no matter what negative number you have, like negative 3 times negative 3, it's going to give you a positive number, right? So if you have a squared term, you can't get a negative value. Since you can't get a negative value, the minimum value is going to be 0, right? The minimum value of this squared bracket will always be 0. But then you need to multiply by this negative sign, right? So this could be this could take on values uh, larger than 0, right? It could be 0, it could be 1, it could be 2, so on and so forth, right? But the larger this number gets, right, eventually you're going to times negative 1. So it's going to become a negative weight, right? So you're going to get like 0 at the top, negative 1, negative 2, and so on and so forth. So the larger this term is, the more negative it's going to be, and the smaller the overall value is going to be. So to minimize these negative weights, you want it to be 0. I hope that's clear, right? Yeah. Okay. So to minimize to minimize the negative value, you want this term to be 0. Okay? And if that's 0, the overall value is going to be negative 4. Therefore, the maximum value of this equation is negative 4, right? If you draw the axis here, the maximum value of your discriminant is going to be negative 4. Okay? So you need to write a series of statements to show this intuition, to prove that the maximum value is negative 4. And this is how you do it. Okay, start with k plus 2 square. This is going to be larger or equal to 0, which means that if you multiply by negative 1 on both sides, the inequality sign is going to flip. Right, the negative of that is going to be at most 0. Okay, and then if we minus 4 on both sides, right, you get negative k plus 2 square minus 4 is going to be less or equal to negative 4. And this is definitely less than 0. So these three steps captures the intuition of what I was explaining just now, like how this form shows that the maximum value is negative 4. Okay, and therefore you can conclude that, okay, since the coefficient of the x squared equals to 1, which is more than 0 in the original equation, this shows that the original graph is U-shaped. Okay, and discriminant is 0. Sorry, the discriminant is less than 0. Then y equals to x squared plus kx plus kx square, sorry, plus k squared over 2 plus k plus 2 is always positive for all real k.